Hey guys, what's the crack? So this video, we're going to go over resolution and absolute uncertainties. Okay, so this is the practical knowledge. Hopefully you learned this when you did the practicals in school. But again, sometimes you don't do the practicals because of class behavior, but it doesn't matter, right? As long as you learned the theory, it's not so much if you did the practical. So again, we need to know what resolution is and we need to know what absolute uncertainties is. This is coming up more and more the last 2 years, okay? So resolution, what does it mean? Resolution just basically is asking you what is the smallest number you can get on your equipment, okay? So we're looking for the smallest number on our equipment. So for example, if you're using a ruler, everyone uses a ruler all the time, you know the smallest number on your ruler is going to be that millimeter, right? So the smallest ruler, the resolution of my ruler, so again, of my ruler, the smallest of my ruler is 1 millimeter. So that's the resolution of your ruler, or 0.1 centimeters, right? You know you've got those tiny little millimeter marks on your ruler. So let's say here we've got our different months and we've got the temperature recorded, and I want to know what was the resolution of my thermometer. Okay, so we're looking for what's the smallest number my thermometer can read. So we can see we've got 31, 31, 30, 29, 30. So the smallest number it can read is going to be that 1 degree, right? It can change by 1 degree. Okay, so it can be like 1 degree, 2 degree, 3 degree, 29 degrees, 30 degrees, right? The smallest number it can give us is 1 degree, and that's why we can get those differences in 1 degree. So just more practice to see if we understand it. Let's say we have an ammeter here. So here's my ammeter, and it might say 5.00. Now, because it says 0.00, I'm thinking, what's the smallest number it could tell me? And the smallest number it could tell me is 0.01. So that's the resolution of my ammeter, the smallest number it could tell me. 0.01, 0.02, 5.01, 5.02. More examples. Let's say we've got a voltmeter. Now, this one is a voltmeter where it's got a little dial, and the dial can switch between the numbers. So rather than being digital, where we just read the number off, again, it's a dial that switches. So what it is the smallest number it can give us. So here is 0, here's 5. So that must be 1, that must be 2, that must be 3, that must be 4. So again, that's not, 1's not the smallest number because we've got these little dashes between 0 and 1. So that must be 0.2, 0.4, 0.6, 0.8. So the smallest number it can give me there was 0.2. So the resolution of my voltmeter is 0.2. Okay, that's the smallest number the voltmeter can give me. Remember, there is no dash there for 0.1. I'd be guessing where that is. So the smallest number is 0.2. More examples. Let's say I'm measuring the mass on a scales or a top pan balance, whatever you want to call it. Again, if we're looking for the smallest number it can give me, 8.45, 8.46, 8.51, 9.00, the smallest number it can give me is 0.01 grams, right? So that's the smallest number we can get there. Now, the next thing is about absolute uncertainties. So absolute uncertainties is a little bit of math that you have to remember to do. So I want to calculate absolute uncertainty. The rule is always half of the range, okay? So if I want to calculate the absolute uncertainty of my mass, what again we're doing is to find that absolute, so ABS for short, to find the absolute uncertainty, U for uncertainty, just to save me time of writing down again. What we're doing is half of the range. Okay, so hopefully you've learned about range in your maths classes. Range is always going to be the biggest number, take away the smallest number. Okay, so what we do is we look for our biggest number that we recorded. The biggest number here is 9.00. So what we do is the biggest number, which is 9.00, take away the smallest number here. The smallest number here, that's a 5, sorry, it's hard to read. The smallest number here is 8.45. So take away 8.45. So always use your calculator. So in your calculator, what you're doing is 9.00, take away 8.45, and you get a number that says 0.55. So that's my range. Now to find the absolute uncertainty, I need to take half of the range. So what we're doing now is a half of 0.55. So I do 0.55, apologies, divided by 2, or a half of it, and you get 0.275. So that's my absolute uncertainty, right? It's half of the range. If you want to be better, because all these numbers are given to 2 decimal places, I should probably give this number to 2 decimal places. And remember, if something is 5 or above, we always round up the previous number, so 0.28. Okay? So again, absolute uncertainty is always just half the range, and you have to remember that. It's not on any equation sheets. Half of the range. So hopefully you find this video, and remember you can always join our online classes or check out my resources for more help.